Hi, I'm Luke Collins with Tech Design Forum, and I'm here with Michael Buehler, who's Senior Marketing Director for the Caliber product line at Mental Graphics. And we seem to be at a point just at the moment where 28 nanometer processes are coming on stream. There's arguments about exactly how well that's going, but it's clearly an issue for right now. So what I'm interested in, Michael, is what will the shift to 28 nanometer demand from designers that they haven't had to do before? What are the new issues that they face?
Okay. Well, thanks, Luke. It's, we have, do I just keep rolling? Okay. So what really we've had is for 28, we're seeing adoption now. So
Right.
It's new customers, and what we're seeing that's different is it's not the usual suspects. There's a lot of new companies that are adopting 28 faster than they have at 40 nanometer. So that brings a whole new class of customers into the mix that we weren't used to having this early in the node. So while people talk about capacity and yields, from a design perspective, we're seeing a very high ramp.
Right. And are those customers, do they have are they a new class of customers? Do they have the kinds of skills that they need to actually work with the process, or are they just attracted by the process and they've got a lot of learning to do to work with it?
So I think that's part of the partnership with the foundries, is to make sure that they don't have to learn on the fly, that we can work with them to help make them successful.
Right.
So that's the class at 28. What we're seeing now, and what a lot of the press release, the discussions we had this node was at 20. So
Right.
20 is coming on just as hard and surprised. Now that's the usual suspects.
Right.
But the type of work that we've had to do to be ready for them has been significant. So talking to the team, talking to the ecosystem of foundries, we think we've done more work and done more preparation for 20. It's probably some of the best partnership work we've done in a couple of nodes. But 20 is tough with the new techniques, new double patterning, new other multi-patterning, new DFM techniques.
Right.
It takes that type of collaboration to get these first designs out.
And what's the impact going to be on the design process of things like double patterning, more subtle control of fill, some of the thermal issues which are coming out?
Well, so they're new features. If you look at the amount of items that we now call physical verification, it's exploded for the last 2 to 3 nodes. If we do our job right, the impact to the designer should be minimal.
Right.
That's our objective. But for the early work, we need to work with lead partners to to get that developed. For example, for double patterning, what we've done is, because that's an error that's contextual.
Yeah.
We've given them not just the error, but we've given them keep out areas that they shouldn't go fix in, just to help make this process faster. Is the first time through different? Yeah. Are we going to get it fixed so it's like every other node eventually? Yeah.
Well, that's kind of the history of the industry, isn't it? It's an industry which is all about turning the impossible into the possible through a series of
because we all want new things like
steps.
Your phone.
New things like my phone, absolutely. So what other trends do you see in the evolution of DFM tools as the process nodes just get more and more complicated, and the physics almost becomes an issue at the architectural level? That's an overstatement, but there is that sort of that flow of constraints upwards.
Right, and you're exactly right. I think what we've seen is a continuing growth of the market to include DFM earlier on the process, and not just for the leading folks, but continuously through the node as new designs come in. And for example, reliability is considered part of DFM. We're seeing a lot of new changes or requests for PERC rule checking at old nodes too. So 2 of our announcements here at DAC were with Tower Semiconductor and SMIC, and they're at 180 nanometer, 130 nanometer nodes.
Were you surprised, or do you?
Well, if I was a perfect marketer, I'd say no. Of course not. We're not surprised.
I knew that. I knew that was going to happen.
The fact is, we went and asked why we didn't need this type of of skills, this type of advanced tool the first time through.
Yeah.
What's changed? Well, what we learned was the customers are putting more complex designs into an older node.
Yeah.
So from a Mentor perspective, specifically from Caliber, that's okay, because if you buy our product, it'll work at the new nodes, it'll work at the old nodes. Anywhere you go with your design, we got you covered on any foundry.
Right.
It's interesting to see this evolution where it's new and then the old becomes new again.
Yeah, and you've got to sort of not back annotate, but you've got to bring those leading edge techniques back up to the older processes.
Right.
And what sort of things are people building in those older processes?
New
challenging
power
designs but in older processes.
Right. What they're doing is a lot of new power control systems, a lot of the non-pure digital. So the big processor still goes with the advanced node.
Yeah.
Right. But now when you can do 2.5D instead of one single chip, some of that analog, it likes older nodes. It likes the higher voltages.
Yeah.
So if you can stuff 4 or 5 different power supplies on it, 3 or 4 voltage systems, and make sure it's reliable, which is what the new checks will do, and the new tools will do, then why not?
Right.
You're talking an $800 wafer versus the $4,000 wafer.
Okay, well, for a final question, how do you feel about the upcoming challenges of 2.5D and 3D from your perspective, trying to provide tools to check that those things will be manufacturable?
Yeah. That's a great lead-on question. So for the basic 2.5D, we think we got it covered.
Right.
Right. For the current existing effort, in fact, we have a product called 3D Stack, and if you already have Caliber, DRC, and LVS, you get 3D Stack as part of the deal, no additional cost. Where we think that true 3D will come into play, and we're seeing this with the early adopters, some of the advanced folks, is when you really start doing logic on logic.
Yeah.
So logic, so you're now partitioning your design instead of being one giant chip into 2 chips.
Yeah.
Then how do you get those signals across? And through silicon vias are part of that process. So we've had a government project with ST in Europe, called Nano 12, which is a big project for a Mentor, that has been working on a TSV model. And as I kind of joked with my staff, I'm a little confused with it because it's a government project that's ahead of schedule and delivering results.
Can't be right.
No, can't be right, but it seems to be working. And those results will be out end of the year, ahead of when the market needs it, which is exactly what type of government-funded project should do.
Right.
So we think we have things understood, but as with everything else, just like we talked about 28, I'm sure there's something that we haven't thought of that we'll have to figure out when we get there.
And that's how the industry works.
That's how it works.
Thanks very much.
Thank you.